So in this video, I'm going to talk about troubleshooting limits that are like this type. So I really want to talk about like common pitfalls. This video is inspired by a quiz that I'm in the middle of grading. And I haven't made a video like this before, so I thought maybe it would be helpful to see like inefficient things or things that you shouldn't do, just as inspiration if you're struggling with this. So I'm figuring that if you're watching this, this might be you right now saying you hate these problems. And so I want to just try to show you like once you kind of get what you're looking for, I think they get a lot better. So maybe seeing like what not to do will help you understand this. So what I'm going to do is I'm going to go through these two problems, which are actually two very similar problems to what I had on a quiz. But what I want to do is I want to focus on the errors that I've been seeing as I'm grading this. So let's talk about this first example. So I've got the limit as x approaches 0 of tan of 5x over x. Okay, so almost everybody, when they look at this, at least on the quiz, they knew that they had to use sine of x over x. But I do want to point out that it should also be clear. So if you just saw this problem out in the wild, so notice that you would get 0 over 0. So that tips us off that we are going to have to do something special because we can't have 0 over 0. And the other thing then is that there's really no other way for me to like reduce this, right? I can't like factor it or use a conjugate or anything like that. So, okay. So I'm going to have to think a little creatively. And normally what happens when I'm thinking creatively is I am going to say, okay, well, this tangent of x is tangent of 5x will be sine of 5x over cosine of 5x. Okay, so actually like one of the things that I've seen go wrong in this problem repeatedly is people not knowing what to do with this x over here. So let's just talk about like how not to accidentally make this harder for yourself right out of the gate. So first of all, this problem means tangent of 5x divided by x, right? That's literally what this means. So I saw a lot of people that interpreted this as multiplying by x, like because they kind of like misread how to read the problem. So this means the top divided by the bottom. So if I take the top divided by the bottom, that's the same as this times 1 over x, okay? And then now for tangent, I'm going to just get rid of all this stuff with tangent and I'm going to rewrite it in the way that I know I should. Okay, so now let's talk about like how do I know that I need to use sine of x over x? Okay, well, I have sine of x here on top and now I have sine and I have an x in the bottom. So once you see sine on top, x in the bottom, and there's no other way for you to really reduce this, that is screaming for you to probably use that limit. Okay, so what I'm going to do is like the next thing that you want to do, so like the other thing that I feel like I've seen in grading these is one, I saw a lot of people not doing this part right. So algebra is algebra, bro. And then the second thing that I saw is people doing really inefficient things at this point. So what I saw were people like multiplying by 5x over 5x. So I understand where this comes from because you see a 5x here and I think everybody knew that they needed to use that special limit. So they see a 5x here, so they just want to like manifest the new 5x. But this is not necessary, right? This extra x is not necessary because I already have an x here. So I'm bringing this up because I think it's important for you to kind of understand efficiency with this. So what I would recommend that you do is when you get to this step, take stock of what you have, put the sine of x and x together, and then come up with a plan. So I've got sine 5x over x, and then what am I left with? 1 over cosine of 5x. Okay. So now I can see that this is 5x, this is x, so I need this to be a 5. So now I can multiply the whole thing by 5 over 5. This is far more efficient than multiplying by another x over x. What I've been noticing is that by multiplying by another x over x, people are getting like confused as to what to do with this, and then they accidentally like end up putting a 0 in the problem. So let me just push forward with the proper solution. So I've got the limit as x approaches 0, sine of 5x. So I want to bring this 5 now over here. So this is going to be sine of 5x over 5x. And then what am I left with? The other 5x on top and the cosine of 5x. Okay, cool. And so now this is going to go to 1, right? And then cosine of 5x, so cosine of 0 will go to 1. So this whole thing equals 5 over 1, so it's just 5. Okay, so what I've noticed is that when people put these extra x's in here, so I want to just kind of point out like a common error, just to, you know, again, sometimes I think it's helpful to like see errors. So let me erase all of this for a second. So if you're one of the people that, you know, kind of went 5x over x, that was what your first thought was. So the issue that I'm seeing with it is that, so somebody will take this 5x over 5x, they put the 5x here, then they like start losing track of x's. So I've seen a couple of times where someone gets kind of overwhelmed now by all these x's. I've also just seen like this x get dropped out entirely. So one of the things that I've noticed that is incorrect is then you might have something like 5x over x and then 1 over cosine of 5x. So here's something that seems maybe a little nitpicky, but I've seen that people will say that this equals 1. This does not equal 1. This equals 0 over 0 as it's written. So what you would have to do to keep this mathematically correct is you'd actually have to go through and cancel out the x's. And so as you can see, like when you add in these extra x's, you're making an extra step for yourself. You're making extra stuff that you're just adding into the problem, so it's just more inefficient. And I think sometimes like we try to add these extra x's to keep us like safe, but this is actually probably going to create more problems for you than you actually needed, because we had a sine of 5x and an x here, so we were almost there for using the limit. Okay, so hopefully that makes sense. Now let's pivot to this other one. So for this one, so I've got, once again, if you just plug in 0, I get 0 over 0. So we have what we need to kind of qualify us for using that limit. So this is also a problem where I saw some very inefficient work. And then again, just what kind of happens from being inefficient. So one, it sucks to not be confident, right? But two, I noticed that it makes you prone to errors. So what I saw a lot of times were like multiplying by 3x over x and then 7x over 7x. So again, this is not incorrect, but it's inefficient, and it can kind of leave you open then for making a mistake. So let's break this up for a second and let's talk about what's more efficient. So I want to break up this part versus the second part. So I think this is a really good habit to get into when you have these fractions and you're trying to work on these sine of x over x problems, because you can kind of now divide and conquer. And so now I need to just take a moment and think. So don't go into computer mode of like, oh, if I just like do this, then it's an algorithm and then I'm going to be safe. Like, think about this for a second, okay? So this is missing what? It's missing its over x, right? Over 3x really. And this is missing what? This is missing a 7x on the top. So really, both of them need an x. So I'm going to multiply by x over x. And then this is going to need a 3. This is going to need a 7. So the more efficient route to go with this is like so. So the x's, 3's, and 7's. So that gets me an x for here, an x for here. It doesn't like give me too many, because again, I just noticed that like people kind of get lost in the work. So you want to kind of stay efficient. So now if I kind of start separating things, okay, so the 3 and the x, so this 3 and this x are going to go under the sine of 3x. So I'll color code it so we can follow it. And then, so for this part, I'm going to take this x and this 7 and put it on top. So 7x, and then I've got the sine of 7x. So you might even find it helpful to maybe like color code like what you're moving, because now I can really clearly see that I'm left with a 3 and a 7. So, okay, I've got 3 on top, 7 on bottom. And now if I go through all of this whole piece is going to 1. This whole piece is going to 1. So in the end, I've got 1 times 3 over 7. So this equals 3 over 7. Okay, so again, if you multiplied by too many things, just like the error that I kind of noticed. So this answer is 3 over 7. So let me just back up for a second and just show you like some errors that I noticed. So I saw that a lot of people kind of got to this point, but again, it turned into like extra x's. So this is incorrect, but I'll go back to if we were in that theoretical case where someone had this x over x. So I've seen people saying that this whole thing goes to 1, which is not true. I've seen like the only thing that you'd have to do here is if you had these extra x's, what you would want to do is make sure that you cancel them out. So again, it just makes an extra step for you, but like you want to be confident in this. So just multiplying by a bunch of random things is not going to necessarily like guarantee that you're going to get to the answer. It's not like a safety net for you. And a lot of times I'm noticing in these quizzes that it ends up creating more problems down the line. Okay, so hopefully this is like a helpful thing of like what not to do. I've not made a video like this before, so if this was helpful, I'd love it if you hit the like button. And if it wasn't helpful, hit the dislike button so that I can figure out if I should make more videos like this in the future. Okay guys, I will talk to you next time. Ta-ta!